Welcome to Live 2000s and Statistical Analysis. Again, we're going to be going over correlation and regression and normal distribution. So let's get into it. A little bit about me: 20 years old, junior marketing major at Howard, former sales co-op at Vanguard, and former AGNC and Product Destined investment real estate fellow as well. I have a lot of interest in data analytics, sales, digital marketing, managerial accounting, and psychology. I also have experiences in public speaking, business management, sales role play, digital marketing, Microsoft Excel and PowerPoint, Adobe Creative Cloud, and Wondershell Filmora. And last but not least, Apple Final Cut Pro. So I keep myself busy in my free time. I added this slide just to give like a quick little rundown of what correlation is. It's basically a statistical linear relationship between two variables, or a statistical measurement, for a better word. It represents a strong positive, strong negative, or weak positive or weak negative relationship between the two variables. Correlation does not always equal causation. Based on the trend line, this nice line just going through the statistical points, we can make strategic business decisions based on our outcome. I don't know if you could tell, but that's something I like to do. Like when I did it with my last video with my linear programming, it's just so nice to see, like, when you have a model, how you can use that model to make these decisions. And that's what we're going to be doing in today's video. So I'd love to do that. The objectives for today: we're going to be forming a hypothesis. We're also going to be creating a model, actually two models. And then we're going to be evaluating whether my model approves or rejects my hypothesis. And then again, with that, making those forecasted decisions, we'll see what it looks like. We'll see how it goes. So here's my hypothesis. I believe that there's a significant positive relationship between warmer months and higher sales, because as I view and observe my data from my sales, I notice that in the warmer months like May, August, July, those type of months, that my sales are a lot higher than those in cooler months. So increased temperatures coincide with seasonal activities such as vacations and back to school shopping. I just believe that there is a statistical relationship between those. So let's see if my hypothesis is correct. Let's see if it's proven correct or incorrect. I'm going to open my Excel file, and I already have a beautiful table of my months and my monthly sales laid out. And these are monthly sales are not exaggerated. I'm looking for the word made up. Yeah. My monthly sales are made up, but they are realistic because I don't disclose my true earnings just for safety reasons and for personal reasons, but they're very realistic regarding my status as a full-time college student. So just keep that in mind. So first, it's pretty easy actually just to see if there's a correlation between the two by just simply creating a scatter plot. And you can do this by pressing insert in Excel. Go to this scatter plot here, and then you have it right there. Actually, I'm sorry, you're supposed to highlight it first, and then you go to insert and then scatter plot here. Now already you can see that the shape doesn't follow a linear pattern, so that there's no correlation between the 2 months. So that means my hypothesis was disproven. However, just me being me, I like to make my graphs pretty. So I'm going to make this pretty and more presentable, and then we're going to be talking about it later and more in depth. So just give me a second. As you can see, it looks much better. I added my titles, my months and time index. Basically, it just gives a numerical value to the months. You can even do this just by adding another column, but I just put, in parentheses time index, so it's less work. And I have my beautiful title. So this is how you would make a scatter plot. And again, there's no correlation between monthly sales and the months of the year. So that means my hypothesis was proven wrong. And you can even, if you press on one of these points, if you add a trend line, you can see one, it's decreasing, yeah, but like it's also not following a linear pattern. That's how you know it's no correlation. You can even go to display equation on chart and display R squared, and it gives you the equations of both. And basically the meaning of this is that one, it's negative, and we can see it's negative by the direction it's going, but r squared means that the closer or the farther it is from 1, that there is no correlation between the two variables. So just a little side note. Yeah, so what if I wanted to add something a little bit more obvious, like a dependent variable a little bit more obvious? Let's say site traffic. Let's say the amount of people who come or who engage or view with my profile gives me more sales. Let's just say the more people, the more sales. So let's add another column. I'm going to call it site traffic. I'm going to do it right here. Yeah. I'm going to insert another column. I'm going to call it site traffic. And I already have my data from my own Excel that I was working on when I was like laying this out and practicing this. So I'm just going to like copy and paste that down. Copy this down here. Okay, so here's my site traffic. It's a little bit more obvious. So the more people that view my profile, engage, like, that type of thing, the more sales I get. Let's see if my second hypothesis is correct. Let's see if it's proven correct or incorrect. Again, I'm going to highlight the two columns. I'm going to go to my scatterplot chart and simply press it, and almost instantly we can see that there is a strong positive relationship between the two variables. And once again, I'm going to make this look a little bit more presentable and pretty. So give me 1 second and I'll be right back. So as you can see, my scatterplot looks a lot better, and there is a strong correlation. You got some outliers there, but if I were to press on one of the scatter points and click on trend line, you can see that it shows, yep, it's going in the positive or upward direction, so that means it's positive. And if I wanted to display my equations, definitely very close to 1 r squared. So yeah, there's a strong positive correlation between monthly sales and site traffic. Now, what if I wanted to represent my forecast, which is basically this equation here, the y equals and then your slope? What if I wanted to make a separate column or another column showing my forecasted sales based off my equation? Well, we can easily do that, and we have two ways to do this. We can either highlight, or first we can either use this equation, or we can either highlight these columns. We can go to data, and then if you don't already have analysis toolpack checked, make sure you have it checked. After that, go to data analysis regression, press OK. I'm going to input my Y range. My Y range in this case is monthly sales. I'm going to include the label, and then my input X range, my site traffic. Make sure I have my labels checked, and I'm going to output this right next to my chart. Yeah. So this is just a more laid out and detailed summary output of our findings. It has basically the same things that we see on our chart. It has the r squared being the same, obviously, like it wouldn't change. It has our intercept and our site traffic. Using summary output is how it shows our significance F value, and basically our significance F value also tells us how significant it is to our data, like how significant our variables are to our data and our findings. And when it's farther away from 0.05, which is the typical, which is significant level alpha, that's how you know that it's very significant. And in this case, it's very far from 0.05, so it's very significant. Unlike this one, the significant value would be a lot closer to 0.05, which means not significant. So yes, or actually significance, excuse me, I meant to say if it's bigger than 0.05, that's how you know it's not significant. But if it's less than, it is significant. So yeah, I caught myself there. Anyway, just to make it easier, I'm going to be using the equation here, so I don't have to reference this table every time. Let me make another column. I'm going to call it forecasted sales, or just forecast actually. I'm going to input the equation equals 0.210 and then I'm going to substitute my x for one of my x values, and we said it's the site traffic, which is our x value. I'm going to then subtract 40.816. And so following this trend line, that means the next amount I would make would be basically 380. And then obviously I can just copy this down by double clicking. So this is how we would use that forecast feature I was talking about, and look at and compare my actual sales with my monthly sales, or excuse me, my actual sales with my forecasted sales. Let's move on to normal distribution, because what if I wanted to find probability based off of my forecast findings? Moving on to normal distribution, I want to find the probability of X sales and how it will affect my curve. So by doing that, I'm going to be making an interactive normal distribution chart. And I first wanted to mention that I had help with making this, so I'm not going to be going fully in depth with it. I'm just going to link the YouTube video I got help from in the description box. But I will talk a little bit about it and put it obviously in the context of this whole presentation, which is about Depop. So also, I'm kind of like whispering. It's now 1:20 a.m. so I'm really trying my best to keep the volume low given that people are sleeping. So I already had filled in my table I have at the bottom right here, and I have pasted my forecasted sales from my other sheets. Let me just give that like a little bit of a highlight so it's a little bit more clear. And these values are pretty easy. The sample size is obviously 12 since we're talking about months in a year, my bad. And I have my operators because in the video I watched, they used that for text formulas. So I included like a box or like a table of operators because I needed that. Also, I have my interactive probability formulas. And obviously I use the normal distribution formula as well. Mean is pretty obvious to find. It's just the average of all of my forecasted sales. My standard deviation, I'm using the sample standard deviation function. My lower limit, in the video they did the B22, they did the mean minus the standard deviation times 4. Don't ask me why they use 4. I use 4 and it made my graph look beautiful, so I'm gonna use 4. So, and obviously the upper limit is just the sum of the two. Starting with the X value, I'm going to be using the sequence function, and I'm just again referencing the video. They started with the sequence function. They started with upper limit minus lower limit plus 1, and there were no columns. I want to start at the lower limit and enter. So I'm starting with the negatives. And for probability, which in this case, we're going to be finding the probability density, which is the height instead of the area. So we're going to be doing the norm distribution function, plug in our X value, and then I have my mean value already over here. So I'm going to click on that, and my standard deviation is right here as well. And then for this one, like I said, probability height, which is false instead of true, I'm going to lock these cells. And afterwards, we're going to press enter, and it's going to, no, it didn't copy it down. I guess I got to do it. Copy it down there. Now with everything highlighted, I can make my normal distribution chart. I'm going to go over here to insert. I'm going to click on, let's do this one with lines. Expand that a little bit. Chart type, 2D area. Here's my beautiful normal distribution chart. And of course, again, we're going to add that nice title. I'm gonna go to chart design, add chart element, and then I want to add a legend at the top. And again, I'm following the video, honestly. So the formula for the z-score is going to be equal sign x pound, and then it's just doing an if statement because we're trying to see if x is greater than or equal to 300, or actually no, if x is greater than or equal to this value, we've got to reference that one. Where is my dollar sign? If x is greater than or equal to that, then return our probability height. Remember, the probability height, not the area. And if not, then don't return anything. You can either put 0 or you can put just double quotes, but I like to put 0. And then drag it down, and here we go. This is our interactive chart. Let me actually change the color. I just don't like these random colors making it look not pretty. So if I wanted to see the probability of my sales being less than $300 based on my viewer engagement and site traffic, the probability will be basically 0.67, and it's represented right here. Now what if I wanted to change it to 500? Oops, I accidentally added slash there. The probability of being less than or equal to 500 is 0.99, or basically 100%, almost 100%. Now what if I change it to a very low number? Almost no percent, 0. Now what if I kind of go closer to the mean of 261? I mean, we kind of already did, but let's say 200. 0.25. So that's how normal distribution works. I like it. And, you know, using the probability of your forecasted sales basically tells you where your likelihood will fall if you were to follow the trend and increase your viewer engagement. So it's really nice to use this as a telltale for making decisions. Thank you so much for making it to the end for today's video. I can't wait to make more of these in the near future. Please enjoy the bloopers, as this took such a long time and it was so aggravating. So many things have been going wrong, but I can't wait to make more, and I'll see you in the next one. Testing. Can you hear me? I'm about to scream. And let me go into it as well. This is so bad. Like, I'm not having a fun time doing this. Not as fun as I thought. I don't know what happened. Oh my gosh. Bro, this wasn't even f***ing... Everyone, welcome back to another applied learning video. Okay, I'll start over. I'm enjoying doing... Oh my...